Hello everyone, welcome to my channel. So in this video we are going to talk about Executor Framework in Java. Before we dive in to know more about Executor Framework, let's take a look at what we discussed so far in this series of lectures. So in our previous videos we talked about how can we create a thread in Java. So basically we can do it in two ways. One, by extending a thread class, or two, by implementing a runnable interface. So these are the two ways to create threads in Java. We also discussed about why we need multi-threading and what are the advantages and disadvantages of using a runnable interface versus extending a thread class. Now, as you know how to create a thread. So why can't we just create threads as we keep getting requests? So let's say you developed a service which saves records into database, and then for whatever reason your service is slowed down, and then you decided to use multi-threading. So why can't we just, as new requests come in, why can't we just create a new thread for every request? So the problem with this approach is that thread creation and teardown comes with a cost, both in terms of the processing power as well as the time, because to create a thread or to tear down a thread, it adds some latency into your overall processing. Not just that, the maximum number of threads that you can create is limited. It's not like you have unlimited resources at your disposal. It depends on various parameters like your JVM, your underlying operating system, etc. And if you end up creating too many threads, you might have seen this error called out of memory error. So you cannot really create unlimited number of threads. And also when you have more number of threads than the number of processors or cores on your CPU, then the threads can sit idle. So basically this would eat up your memory, and then it can affect your garbage collection as well. So there are some disadvantages of creating limitless or unbounded number of threads. So in order to fix this issue, what we can do is we can create a pool of threads. This is very similar to database connection pools. You guys might be using that. Like when you want to talk to a database, you just don't use unlimited number of connections to it, right? You create a pool of connections, and whenever you need to talk to a database, you take a connection from the pool, you talk to the database, and then once you're done with it, the connection goes back into the pool. So this is pretty similar for threads as well. So you would create a pool of threads, and then whenever you need to process any tasks, you would utilize that thread from the pool. And once you're done with your processing, the thread goes back into the pool and it is ready to serve the next task that comes in. So this is basically the concept behind the Executor Framework. So the Executor Framework provides various components to manage these worker threads that are in the pool. So java.util.concurrent package provides with the ThreadPool implementation as part of the Executor Framework. If you think of it, it is basically like a producer and consumer pattern. So producer is the requests that are coming asking you to perform a certain task, and the consumer is nothing but these worker threads which are present in the pool, which grab these tasks that come in and then process them. So usually all the threads in the pool, they are also backed by a queue. I'll get into more details about the queue as we discuss further. And each of these pools are also defined with the execution policy. So basically this execution policy would dictate like in which order should I execute the tasks that come in, how many maximum number of threads can I spin up, and what should I do if there are excess number of tasks than that I can process, and what is the task rejection policy, basically like when should I reject a task that comes in. So all these can be defined by the execution policies. So these are some of the key features of execution framework. Now, how can you create a thread pool? So basically thread pool can be created using executors class. It has some static factory methods which you can invoke. As you can see, there are some of these variants. There are other variants as well which I haven't mentioned here, but these are some of the key variants which we often use. First one is a newFixedThreadPool class. As the name suggests, you have fixed number of threads in this pool. Next one is the newCachedThreadPool class. newCachedThreadPool. This thread pool size is not limited. Next one is a single threaded executor. Basically you have just one thread in the pool. If you want to implement your tasks in a sequential manner, then you'd probably use a single threaded executor. And the last one is newScheduledThreadPool. This is if you want to run your tasks at regular intervals, something like a cron job. Not just that, you can also create a custom executor service as well with your own rejection policy, with your own queue implementation, etc. So these are some of the variants that we are going to cover in this lecture and also in the following lectures. Now let's talk about the executor lifecycle. So executor service can basically be in three states. So it can either be in a running state, or it might be shutting down, or it is already terminated. These are the three possible states. And in order to manage the lifecycle of an executor service, we have some other methods available as well. So we will discuss these methods after we start digging into the thread pool creation, etc. In this lecture, we are going to talk about newFixedThreadPool. So as the name suggests, the thread pool size is limited. For example, if you want to, if you create a thread pool with 10 threads in it, that is the maximum number of worker threads in that pool. So the minimum pool size, which we call the core pool size, and the maximum pool size is basically the same in case of a fixed thread pool. And the maximum number of threads that can be created is defined by the maximum pool size. As I said earlier, every pool is backed by a queue. So in this case, the newFixedThreadPool is backed by a LinkedBlockingQueue. So this queue size is unbounded, and the tasks are executed in a first in first out order. So why do we need a queue basically? So let's say that your pool size is 10 threads. Okay, there are 10 worker threads. So that means if you submit 10 runnable tasks or 10 callable tasks to the pool, it can concurrently run up to 10 threads. What if you submit 20 tasks at once? So if you submit 20 tasks, then the first 10 tasks that you submit will be picked up by the worker threads, and as they are processing, and since all of them are busy, the rest of the 10 tasks would end up in the queue. Now once any of the worker threads finishes its current task and is ready to take up the next task, it would go to the queue and it would pick the next task available in the queue and it starts processing it. So that is the use of the linked blocking queue. Now for whatever reason, if a thread dies by throwing some exception, then what would happen is a new thread would be automatically spun up, and then it would be ready to start taking the tasks in the queue. Now when do we go to a fixed thread pool? Fixed thread pool is usually a good choice when you want to limit the number of concurrent tasks. For example, you know that your CPU has, let's say, a maximum of 10 cores, and you know that it cannot serve beyond, let's say, 20 threads. This you can come up by doing some performance testing and stress testing, etc. So once you know the limitations of your system, then you can define your thread pool accordingly. So that is when a fixed thread pool would be advantageous. So I hope you understand some of the basics of a new fixed thread pool. Now let's dive in and then write some simple code to understand how it works. So before we get into fixed thread pool, let's see what we already have, which we have used in our previous lectures. So we have this simple class called student, and it has this name field in it. And we have the student service, which accepts the student class. It waits for about a second, and then if the student name is null, it throws an exception. If not, it just prints the statement and it returns a random UUID, which we can consider it as a student ID. So this is what we got currently. Now let's get into creating fixed thread pool. So how do we create a thread pool? Let's see. So we can create ExecutorService, which is part of java.util.concurrent package. ExecutorService. Then we would call the static methods that we have in the executors class here. So this is what we are looking for, new fixed thread pool. And it accepts one variant of it accepts the number of threads that you want to be in the pool. So let's say we want to have 10 threads. So what this would do is it would create a thread pool with size of 10. If you look into this definition, right, so you would see that it is accepting threads, and then it is calling this new thread pool executor constructor with these parameters. So this is nothing but the core pool size, which is basically the minimum number of threads. This is the maximum number of threads in the pool. In this case, they're both the same. And since you always have to maintain n number of threads, your keep alive time, basically how much time you want to keep your idle thread to be. So this is infinite in this case because you always have to maintain n number of threads. And it is backed by a linked blocking queue, as we discussed earlier. All right. Now let's get back here. Now, how do we use this executor service? Like, how can you submit a new task to it? So the way to do that is, before we go there, let's create our student service, instantiate student service here. Let's call this student service, new student service, and let's create a student object, student constructor takes a name, so let's give him a name. Let's call him test student. And now if you want to call if you have to submit a task, what you need to do is executor. So let's make it static so that it is accessible to us. So we'll say ExecutorService.submit, and it can take a runnable or a callable tasks. Now let's use a lambda expression here, and what we can do is we can say student service dot save student, and then we can pass the student. That's it. So this is how you submit a new task. So once you submit this task, the thread pool that we just created, one of the 10 threads would pick up this task, and it would run the code that you have here. So basically it would run these lines of code. Okay, now let's run this and see what happens. So as you can see, it's saying saving student is completed. It did not basically wait for it. So that completed is printed here. Saving student is completed, but it did not shut down. You can see the main method is still running. We'll look into this later on to see why this method is still running and why hasn't it really terminated. Okay. Now this student service, if you see, it is returning a UUID, or basically the student ID. Now how can we access that ID here, or how can we get that ID? So if you look into this method here, right, so it returns a future here. So this is, we can use this object to access whatever the return type that is returned by this method in here. In this case, it's a string, it's an ID. So if you want to do it, what you can do is you can just say, you can introduce a local variable here. As you can see, the future type is string. That is because your save student returns a type called string. If you make this as an integer, for example, so this will complain now. So what you can do is you can make this integer as well, something like that. So this is how you would change it. But let's go back to keeping it as a string. And now if you run here future.get, so this would give you the string that you're looking for. So let's call this student ID. So now this is complaining because we haven't handled the exceptions. So we can surround it with try catch block here. And once we have the student ID, let's just print it to see that we are actually getting back the value. Let's say student ID and then print the student ID. So as you can see now, so we submitted a task and then we did a future.get here. We printed the return value that we received there, which is the student ID. And then that's it, we finished it, right? Now, one thing that you need to notice or observe, keep in mind is that whenever you do future.get, it actually blocks your thread. For example, let's say the student service is in here, it's waiting for like 1 second, right? So let's make this 10 seconds instead. Okay, now let's run this one. And then let's say we print a statement here saying that this thread is waiting. And then once it's done waiting, we'll just say I'm done waiting. Okay, now let's run this again. So as you can see, it just printed saying I'm waiting, and then now it is waiting for this 10 seconds to elapse. So it would wait for the 10 seconds and then it printed I'm done waiting, and then it printed the student ID here. So this is really important that whenever you run future.get, from whichever thread that you run that command, that thread would be blocked until that future.get returns a value or it is done its processing. Now, how do the second thing that we want to look into is, now we know how to get a return value from a task that you have submitted. Now what if the save student has some exception? Now how do you access that exception, right? So in this case, if you look into student service is throwing a exception when the student name is null. So it throws this exception saying name cannot be null, right? So if you want to handle this, basically whenever you do a future.get, and if that particular thread throws any exception, it would land in this execution exception. So now let's test that. Okay, now let's pass a null in the name field here, and now let's run this one, and let's reduce this time back to 1 second. Yeah, let's stop and rerun. So we'll look into that issue on why the main thread doesn't run to completion. Okay, so as you can see here, this execution exception has caught this exception here saying that name cannot be null. So if instead of throwing exception, if there is any custom exception, then you can catch that in here, and then you can handle it accordingly. Maybe you might want to retry it, or if you want to just log it or throw some other exception, that depends on your particular use case here. So these are some of the possibilities that can happen. One, you get a proper return value and then you process it. Or two, an exception is thrown by the thread and then you catch that exception and you deal with it accordingly. So these are the two possibilities. Now let's go back and see why the main thread doesn't run to completion. Okay, now let's see this one. So as you can see, it has finished its execution, but the main thread hasn't really terminated. This is because your executor service and then the thread that you have created, they are still running. So the thread pool is the threads in the thread pool, they're still waiting for new tasks to come in, and you haven't really shut down the executor service. Now if you go back to a lecture here, as I said, or to the slides in here, as I said, there is a life cycle to it. So currently the executor service is in running state, and you haven't really initiated any of these commands here to shut down the executor service. So once you do that, then it would go into the shutting down phase, and after it shuts down, it would go into this state called terminated. Let's see how that works. Before we go there, let's also discuss one more topic about the linked blocking queue and see how it works. Okay, let's see. So instead of a single student here, let's create 100 students. Okay, and then let's move let's not worry about future for now. Let's just submit it, and then within the student service, let it wait for like 100 seconds. We can get rid of this for now, we don't really need it. And then in here, let's just say we'll print out a line saying I'm waiting. This is main thread. Okay, we'll submit 100 students, but our pool size is only 10. Now let's see what would happen to the rest of the 90 students, okay, or the 90 tasks that you're actually submitting it here. So just for the sake of this example, I'm not really looking into the return value from these threads. Rather, I'm just submitting them. Okay. Now let's debug this and see what happens. So in here, if you look into this executor service, right? So now all 10 threads, because we gave a wait time of about 100 seconds, all the 10 threads are blocked currently, right? Now, if you look into your work queue here, this is our linked blocking queue, and then its size is 90. So what this means is that all the 10 threads, that you have in the pool are busy because all of them are blocked on this wait time here, and the rest of the 90 tasks that you are submitted, they're waiting in the pool, they're waiting in the queue. So once any of these tasks get completed, then they would automatically pick up one of these tasks in the queue and they would start processing. So that is the advantage of the linked blocking queue. That makes sense? All right. Now let's go back and let's just create a single student instead of n number of students. Okay. So we are creating a single student and then we are submitting it. Now instead of 100 seconds here, let's bring it down to 10 seconds. Okay. And then here, how can we shut it down? So what you need to do is, if you want to shut down an executor service, there are multiple ways to do it. One method is to actually run this shutdown, called the shutdown method on it. So what this does is, this is a graceful way to shut it down. What this means is that whatever the tasks that are currently running, it would let them run to completion and it won't ask any new tasks to be submitted. This is what it means. So it would wait for the currently running tasks to run to completion. This, you can test it this way. So as you can see, this thread is currently waiting, student service thread, and then it would wait for 10 seconds, and then even though this is submitted, it would still wait for this tasks to complete. I mean, let's try one other way to know that we have actually issued the shutdown and then we are waiting. So what we can do is, and just print a line saying issued shutdown and waiting. Let's see if it actually waits here or not, and then we can, yeah, let's run this. So if you want to test this right, there is a dirty way of doing this. What we can do is, while ExecutorService dot is terminated, we can run this in a loop. It would look ugly, but if maybe we'll reduce this to, yeah, let's run this and see what happens. Or we'll add a delay here so that it won't look that bad. So you issue the shutdown command and then you wait for it to be terminated. So while it is not terminated, you wait for a second, you print the statement, and then you continue this loop. So now let's run this and see. So as you can see, it keeps on waiting for this 10-second interval. It's waiting on the thread basically. It has issued the shutdown command and it is waiting. After 10 seconds, it has exited. Now you can see the main thread has successfully terminated. This is because it gracefully waited for the thread to complete and then it finished its execution. Now there is another way to do it as well. So what you can do is, you can just say shutdown now. So when you run shutdown now, so what happens is, this immediately terminates all the tasks that you're running abruptly. It doesn't really wait for them. It's not a graceful way to shut down. Now if you run this and see, or to test how it works. So as you can see, it did not wait for this thread now for 10 seconds. Rather, this thread, since it was waiting for 10 seconds, and meanwhile, since you issued the shutdown now immediately, this particular thread this exception was thrown here because that thread was interrupted. So that is why you received an interrupted exception here. And then it immediately finished to completion. So this is how shutdown now works basically. Now there is another way or a proper way to actually do this. So instead of I don't really recommend this way in production, because what if one of your threads is blocked indefinitely? So that means even your main thread would be blocked, or the calling thread would be blocked indefinitely, and you can never really shut down your service gracefully. Rather than that, what we can do is we can use this method. The other method is ExecutorService.await termination. So what this would do is, after you initiate a shutdown, let's say you want to wait for 5 seconds instead of 10 seconds. Okay, so you'd say time unit dot seconds, or if you want you can maybe keep it 15 seconds. Await termination, and then let's surround it with try catch again. And here so you can wait for 15 seconds here, immediately issue ExecutorService.shutdown now. So you can do this one. So when you run this, what happens is that, so you issued shutdown and then you only wait a maximum of 15 seconds. For example, if one of your threads is taking a really long time, like this takes maybe 100 seconds, but after you wait for 15 seconds, you would kill all the threads that are still running. So this is really helpful if you are in a production environment and if you want to kill all the tasks after you initiate shutdown. So if you run this, right, so though the student service is waiting for 100 seconds, your executor service here, it would only wait for 15 seconds, and after 15 seconds it would initiate this shutdown now command. Then you'll probably see, or you will see, an interrupted exception here. There you go. So the sleep is interrupted. This is coming from this thread in here, and then your main thread has run to its completion. So if you go back now, I think now you might understand this, right? So shutdown is graceful shutdown of your executor service. Shutdown now is to actually abruptly shut it down without waiting for your tasks to complete. And then we have explored these methods as well, like is it terminated or await termination. Now let's explore one more behavior here. Okay, so after you initiate shutdown, let's see what happens if you try to submit a new task. Okay, save student, and then we'll add another student here. So we are trying to save another student after we initiated the shutdown request. Now let's see what happens. As you can see, this is the exception that you're running to, rejected execution exception. So what this is saying is that since you have already issued the shutdown command in here, it would wait for the existing tasks to complete, but it would not accept any more new tasks. So this is basically your rejection policy. If you go back to our slides in here, so as I mentioned, every task or every pool has a rejection policy as well. So in this case, this is the rejection policy. Any new tasks that comes in, it cannot be completed after you initiate the shutdown. This behavior, you can customize it according to your needs if you want to. So I hope now you have a good understanding of how a new fixed thread pool works. So that's all I have in this lecture. So in the next video, we will talk about how a new cached thread pool works. If you liked my video, please do share and subscribe. Thank you very much.